This video is on block and stream ciphers. Symmetric encryptions can be categorized into either block or stream ciphers. The difference between the two is how the data gets encrypted. A block cipher breaks down plain text messages into fixed size blocks before converting them into a ciphertext using a key, while a stream cipher breaks a plain text message down into single bits, which are then converted individually into ciphertext using key bits. Block cipher transform plain text one block at a time. For example, 64, 128, and 256 bits at a time, while stream cipher converts plain text one bit or byte at a time. This makes block ciphers slower since an entire block has to be accumulated before the data is encrypted-decrypted. Stream cipher, on the other hand, encrypt and decrypt bits of data into individual symbols one at a time. Let's talk about block cipher in a little bit more detail. Block cipher takes fixed size blocks of plain text and it produces fixed size blocks of ciphertext. It requires an IV, initialization vector, to function, which is a random sequence of characters used to encrypt the first block of characters in the plain text block. The final result ciphertext for the first block of characters acts as the IV for the subsequent blocks. Therefore, symmetric cipher produces a unique ciphertext block for each iteration, while the IV is transmitted along with the symmetric key and does not require encryption. Block cipher offers high diffusion, which is if a single plain text block were subjected to multiple encryption iteration, it results in a unique ciphertext block for each iteration. And this makes the encryption scheme relatively tamper-proof because it's difficult to insert symbols into a data block without detection. However, block ciphers do have a high error propagation rate, since a bit of change in the original plaintext results in an entirely different ciphertext blocks. Now let's get into stream cipher a little bit more. Stream cipher encrypts a continuous string of binary digits by applying time-varying transformation on plaintext data, which is why this encryption works bit by bit, using key streams to generate ciphertext. The stream cipher combines the key stream with the corresponding digits of the plaintext using exclusive or XOR operator. The XOR operator creates the new binary values which makes up the ciphertext. Encryption schemes that use stream ciphers are less likely to propagate system-wide errors since an error in the translation of one bit doesn't really affect the entire plaintext block. Also, stream encryption occurs in a linear, continuous manner, meaning it's simpler and faster to implement. However, stream ciphers do lack diffusion since each plaintext digit is mapped to one ciphertext output. One thing to highlight here is that stream ciphers do not validate authenticity, which makes them vulnerable to insertion, which is why stream ciphers are mainly used to encrypt data in applications where amount of plain text cannot be determined or in low latency use cases. Also, stream ciphers utilize only the confusion principle to transform the data, ensuring data confidentiality. Block ciphers, on the other hand, use data diffusion and confusion to encrypt plain text. Block ciphers can therefore be used to implement authenticated encryption for enhanced security. Another issue with stream cipher is that it uses exclusive OR operation on the plain text to create the ciphertext. Stream-based encryption is easily reversed by storing the ciphertext outputs. Block ciphers encrypt more bits at a time, making the decryption more complex.